Welcome to Creighton's Centripetal Cite, where I pull you in to a world of motion. Today we'll be focusing on Newton's laws of motion. For the first part of this demonstration, I'll be focusing on Newton's first law of motion, which states that an object at rest remains at rest, and an object in motion remains in motion unless acted upon an unbalanced force. Now for part one of the demonstration, this ball will be the object. Notice that it is still right now. That is because there are no unbalanced forces acting upon it. However, when the unbalanced force of my hand hits it, I move the ball in the direction towards the pins. Now I'm going to talk to you about the other two parts of the presentation, Newton's other two laws, the second and third law. Now, the second law of Newton's motion exclaims that acceleration of an object increases as force increases and decreases as mass increases. Now, I'm going to show this in two parts. The first part, I'll need my handy-dandy orange ball back. For this part, I'll be showing how acceleration affects force. I'll be using a smaller acceleration for the first trial and a larger acceleration for the second trial. I'll be using the same ball to make sure that the mass doesn't change, affecting the formula. For trial one, as you can see, not nearly strong enough. I'm gonna have to try much harder, put more acceleration in, put more work in if I really want to get a strike. Trial two, brilliant. More acceleration, more force. Can't argue with science. Now for part two of Newton's second law, demonstration. Now for this part, I'm going to change the formula of force equals mass times acceleration to change it so that it equals acceleration equals force divided by mass. So what I'm going to do is take two balls, orange basketball, less massive, compared to a larger, more massive tennis ball. I'm going to be applying the same force to them and seeing how the acceleration is changed by their mass. First, for the more massive ball, same force, not enough. Second trial, same force, much better. So obviously, the less mass of the object, the higher the acceleration. Now for Newton's third law of motion. Newton's third law exclaims that for every action, there is a counteraction opposing it. For this part, I'm going to be aiming, once again, handy dandy orange basketball against these new pins. Now, unlike the chess piece pins, these pins are much more massive. So the reaction against the ball will be much greater. Hopefully, if we are correct, if I use the same force, as you see, unlike the chess pieces, when the ball barged through the pieces, these pieces, since they are much more massive, had a greater opposing force, which then stopped the ball, allowing only one piece to be knocked down. That's Creighton's centripetal Cite. See you next time as we tune in to more science.